Thank you for attending the Japan CCS session. My name is Shiro Tanaka with Japan CCS, and I will be the MC for this session. Our session is entitled Deploying Japan CCUS Technology in Asia through Asia CCUS Network, the Results and Future Outlook of the Tomakomai CCS Demonstration Project. First, a presentation will be given by Mr. Shigeru Kimura, Special Advisor to the President on Energy Affairs of ERIA, Economic Research Institute for ASEAN and Asia. ERIA and the Ministry of Economy, Trade and Industry of Japan are promoting the Asia CCUS Network, an international industry, academia, government platform aimed at knowledge sharing and improvement of the business environment for utilization of carbon capture, utilization, and storage throughout the Asia region. Mr. Kimura's presentation is entitled Deployment of CCUS in Asia Region and Role of Asia CCUS Network. Mr. Kimura, please.
Thank you very much, Tanaka-san, for your kind introduction, and good afternoon, all of you who are participating to the Japan CCS webinar, which is part of the COP26 virtual pavilion. Today, I'd like to introduce the Asia CCS network and emphasize importance of CCUS in Asia regions. Firstly, I talk about the ES Energy Outlook. ES stands for the East Asia Summit, consists of the ASEAN 10 plus 8 countries. But ES Energy Outlook is not include the Russia. In ES regions, energy efficiency and renewable is a high priority energy policies, so that ES countries report energy efficiency and renewable target regularly to the coordinating country in ES regions. Then using the energy outlook model, area assess the target, how the target is contribute to the energy saving potential, energy saving, and CO2 emission reductions. In this case, area produce the two energy outlook, BAU and APS. APS reflect the target. Then saving potential, energy saving potential defined as the BAU minus APS. In terms of the final energy consumption and primary energy supply, and apply the same approach to CO2 emission potentials. Today, I'd like to show the BAU CO2 emission outlook result of ASEAN, China, and India. Then ASEAN increase its CO2 emission 3.2 times from 2070 to 2050. India 3.3 times, 3.0 times. Then China is slightly decrease its CO2 emission around the 6% from 2070 to 2050. Then this figures is clearly indicate the which sector and fuel emit CO2 significantly. So that we understand it's a major sector of the CO2 emission in the Asia region is the first power sector due to the lot of coal and gas consumption. And the second is the final use of the oil and the coal, which are mainly consumed in the industry sectors and transport sectors. Thus, CCS can be applied for the power sector as well as the large factories to produce iron, steel, chemical products, and cement. Referring to the previous slide, I'd like to show the one of our low carbon energy pathway in Asia regions. For power sectors, is the Asia region they still depend on the coal and gas power generation in the future, so that apply CCS to existing and the new coal and gas power plant. It is essential. And fuel switching from coal and gas to ammonia and hydrogen. Now, currently, thermal power generation fully depend on the coal and gas, but in the future have to shift to the low carbon fuels such as ammonia and hydrogen. In this case, apply CCS to production of hydrogen blue hydrogen is a very important issues. And the finalized consumption sectors apply the CCUS to CO2 intensive factories such as the iron steel and chemical product sectors, in industry sectors. Then transport sectors is fuel switching from gasoline, diesel to the electricity and the hydrogen is very, very important and essentials. But I guess the still gasoline and the diesel vehicles will remain in the future around the year 2050. Thus, DAC, direct air capture with CCUS is crucial. So that I want to say the CCUS is an important and effective technology to reduce the CO2 emission in Asia regions. Then considering the importance of CCUS in this region, ERIA organized the third East Asia Energy Forum last year, November. Then discuss about the CCUS and the carbon recycling in the ASEAN regions. One of the major outcomes of the third East Asia Energy Forum is to establish the collaborative framework together with all the stakeholders of CCUS, which are industry, academia, government, to promote development and commercialization of CCUS in EAS Asia regions. Then, in addition, there was a policy movement. 14th East Asia Summit Energy Ministers meeting was held same month in last years, and participated ministers noted the importance of CCS and the carbon recycling, and ministers also welcome the cooperation initiative led by the Japan and the ERIA to establish the Asia CCS network. Then, through the several steps after the 14th EAS EMM, Asia Ccus network was officially launched during the first Asia Ccus network forums, and ERIA is appointed to the secretariat of the Asia Ccus network. Many of the energy ministers of ES countries and international organizations is participated the first Asia Ccus network forum and delivered their congratulatory speeches and expectation to ASEAN. Then we had more than 600 audience every day during the forum. Then I move on to the concept of Asia Ccus network. Firstly, I talk about the vision. Vision is through cooperation on development and the deployment of CCS in the ES region, Asia regions. Network will contribute decarbonization of the regions. In order to achieve the vision, we have the 3 milestones for over the per each 5 years, each 5 years. First 5 years, 2020 to 25. Milestone is a launch of the Asia Ccus network, which is served as a platform to development of CCUS. So far, Asia network is already established. Then the second 5 years is 2025 to 30. Milestone is development of a project, CCS project, and the business environment. How private sectors engage the CCS business in Asia regions. Then the third one is after 2030. Milestone is decarbonizing Asia economic zone with focus on the CCUS. Then, to facilitate deployment of CCUS in ES region, Asia region, ASEAN has 3 missions. First, promote knowledge sharing through holding annual forum, conference, workshop, and meetings. Second, conduct research studies on technical, economical, and the legal standard of CCUS. Third, holding the capacity building training to increase common understanding of the CCUS in Asia regions. Next, I talk about the institutional framework. ASEAN has the two kinds of the membership. First one is the members, consist of the EAS 18 countries. So far, ASEAN 10 member states plus Australia, India, Japan, United States is registered to ASEAN. Then the second membership is the supporting members. It consists of the private and public companies, academia, financial institutions, including a commercial bank, regional and international organizations. In addition, ASEAN set up the advisory group to consist of the policymakers and the CCS experts. And advisory group is provide this advice to Secretariat area in terms of the deployment of the CCUS in Asia regions. So far, number of the membership around the 200 as of the October 1st this year. Then each milestone include the action plan, so that I show you the first 5 years action plan, 2020 to 25. We have 4 action plans. First one is knowledge sharing and capacity building training. ASEAN already conduct the 3 knowledge sharing conference to invite IEA, US DOE, and the OGCI as the speakers. ASEAN also conducted the 3 days capacity building training in early October 2021 to focus on the technology of capture, transport, storage, utilization of CO2. Then second action plan is launching new project, CCS project, and proceeding with existing project. Third action plan is a building of storage potential mapping. Storage potential mapping is very, very important in order to deploy the CCUS in Asia regions. In this regard, ASEAN will apply the literature survey to refer to the existing report of the storage potential. And after that, ASEAN will conduct the deeper research studies to produce more precise storage potential mapping in Asia regions. And based on the major outcome of the 3 action plan, ASEAN finally produced the roadmap of CCUS, and this roadmap to show the clear path of the deployment in CCUS in Asia regions. Then the launching of pilot CCS project is a crucial action plan of the ASEAN. Then pilot CCS project surely reflect the CCS value chain, which consists of the capturing CO2, utilization of the captured CO2, transporting CO2, and storing CO2. And based on the launching the pilot CCS project, ASEAN surely prepare the some scope of work for the pilot project. Then, how to launch the CCS project? ASEAN consists of all the stakeholders of CCS activities, which are government and the public and the private companies, institutions, academias, and the financial sectors, and the regional and international organizations. So that through collaboration of the members and supporting members of ASEAN, ASEAN will initiate the pilot CCS project, hopefully until 2025. In this regard, ASEAN have to utilize expertise and experience of CCS technology owned by the Australia, Japan, and the United States. I'd like to conclude the my today's presentations. First, Asia region is will continuously depend on the fossil fuel for the power generation and the road transport sectors. So that CCS is one of the important options for Asia region to achieve the low carbon energy transitions. Thus, Asia-Ccus network has established in this region, and its vision is a promotion of the CCS deployment in these regions. Basically, deployment of CCS is a purely technology-oriented matters. Thus, advanced CCS technology being owned by the developed countries such as Japan indispensable. In addition to the technologies, appropriate legal and financial framework will surely improve CCS business environment in the Asia regions. Last but not least, Asia Ccus network is set up its website, so that very much appreciate audience to access to the Asia Ccus network website to get the updated CCS information regarding the Asia Ccus network activities. Thank you very much for your attention.
Thank you, Mr. Kimura. Next, Mr. Yoshiro Sawada, Corporate Advisor and General Manager of International Affairs Department of Japan CCS, will give a presentation entitled The Results and Future Outlook of the Tomakomai CCS Demonstration Project. Mr. Sawada, please.
Thank you for the introduction. I am very honored to have the opportunity to make a presentation about the Tomakomai project. First, I'd like to show you a short video.
CCS is a technology that captures CO2, considered to be the cause of global warming, and stores it deep underground. CCS is a crucial technology for reaching net zero emissions. The Tomakomai CCS Demonstration Project, Japan's first large-scale CCS demonstration project, was launched in 2012 by the Japanese government in Tomakomai City, Hokkaido, Japan. The project has been carried out over 9 years in the western part of the Tomakomai port. The initial target of 300,000 tons of cumulative injection was achieved on November 22, 2019. Aiming for the practical use of CCS technology, the objective of the project is to demonstrate the viability of a full-chain CCS system from capture to storage and prove that CCS is safe and reliable. The Co2 Source is a gas supply facility in the Idemitsu Kosan Hokkaido refinery, adjacent to the Tomakomai demonstration plant. Gas containing carbon dioxide is sent by a pipeline to the Tomakomai facilities. In the Tomakomai capture facilities, an advanced energy-saving absorption process is applied. The captured carbon dioxide is then sent to a compression facility to be injected into deep offshore sub-seabed reservoirs. The 2 injection wells in this project were drilled from onshore toward 2 offshore sub-seabed reservoirs using directional drilling technology. One well targets the Moebetsu Formation, a sandstone layer between the depths of 1,000 to 1,200 meters. The other well extends into the Takinoue Formation, a volcaniclastic layer between 2,400 to 2,800 meters deep. By drilling the wells from onshore to offshore, drilling costs were saved and disturbance of the marine environment, port, and fishing activities was avoided. An extensive monitoring system was established to monitor the behavior of the injected CO2, as well as natural earthquakes and microseismicity. Temperature and pressure sensors were set in the injection wells to monitor the reservoir conditions. There are 3 observation wells equipped with temperature and pressure sensors, as well as a total of 11 seismic sensors. In addition, an ocean bottom cable equipped with 72 seismic sensors and 4 ocean bottom seismometers are continuously monitoring the sub-seabed conditions. Now, a brief introduction of the results of the Tomakomai project obtained to date. Microseismicity monitoring, conducted by the observation wells, the OBC, and the OBSs, detected naturally occurring events in the deep subsurface prior to, during, and after CO2 injection. But none have been attributed to CO2 injection. In addition, a total of 7 seismic surveys prior to, during, and after the CO2 injection were conducted in order to monitor the behavior of the injected CO2. The results of the seismic surveys indicated the evolution of the CO2 plume at the reservoir. Seasonal marine environmental surveys conducted at 12 survey points above the CO2 injection points detected no seepage of the injected CO2. The monitoring activities comprised of microseismicity monitoring, seismic surveys, and marine environmental surveys have confirmed that the CO2 is being stored safely and securely. The Co2 Absorption Tower uses activated amine to absorb the carbon dioxide. The 3 towers comprising the main equipment in this advanced process achieved world-class energy efficiency. Through numerous opportunities for communication with a wide range of residents, including the young generation, the project is being conducted while securing the understanding of the local community. Looking ahead, the Japanese government is currently planning to demonstrate ship transportation of CO2, which will be captured and liquefied at a coal-fired power plant in Maizuru City and transported to Tomakomai. The government is aiming to start the ship transportation demonstration in 2024, which is expected to be the world's first CO2 ship transportation for CCUS. With a view towards the social implementation of CCUS around 2030, the objective of this demonstration is to establish ship transportation technology that will lead to long-distance and mass transportation, as well as cost reduction. Japan will continue the communication of its CCUS technology from Tomakomai to Asia and the world.
Thanks for your kind attention to the video. I would like to make a presentation about the Tomakomai CCS demonstration project. This is an outline of my presentation. First is a project overview and key results. Next, the future outlook of Tomakomai project. And last, investigation of potential storage sites. First is a project overview and key results. The main objectives and tasks of the project are to demonstrate a full-chain CCS system from capture to storage, to demonstrate that the CCS system is safe and reliable, to remove concerns about earthquakes by the data collected, and to disclose project information and data, and enhance understanding of CCS by local residents. This slide summarizes the features of the Tomakomai project. It is the first full-chain CCS project in Japan from CO2 capture to storage. A world-class energy-saving CO2 absorption process is applied. Deviated injection wells from onshore to offshore subsea reservoirs were drilled. It is the world's first application of the directional drilling to CCS. An extensive monitoring system has been deployed. It is the world's first CO2 geological storage in an area near a large city. This slide shows the key results of the project. We have successfully achieved the target of 300,000 tons of CO2 injection. The safety and reliability of CCS system has been demonstrated. We have dispelled concerns about earthquakes. Our public outreach program has been largely successful with no major opposition to the project. This slide shows the issues for social implementation of CCS based on the results of the Tomakomai project. For commercialization of CCS, the first challenge is to reduce the cost. In particular, the cost of CO2 capture must be reduced. Next, it is necessary to develop a ship transportation system for liquefied CO2 in Japan. Because of the distances between the CO2 emission sources and suitable storage sites. This will be explained later. In order to deploy CCS on a large scale, it is essential to investigate and secure suitable sites for storage that will allow for large-scale storage. This will be explained later. In addition, for commercialization of CCS, it is essential to develop the business environment. Next, for the future outlook of the Tomakomai project. In 2019, the Japanese government announced that it would utilize the Tomakomai CCS Center as a carbon recycling demonstration center. Japan CCS is supporting a government study. In August this year, Ministry of Environment commissioned a consortium including Japan CCS to conduct a research project to produce jet fuel from CO2. Due to the distances between the CO2 sources and storage locations in Japan, long-distance transportation by ship is believed to be more feasible than land transportation by such means as pipelines. In order to verify this, NEDO, New Energy and Industrial Technology Development Organization, commissioned a project to demonstrate long-distance transportation of CO2 to consortium led by Japan CCS. The CO2 ship transportation project consists of 3 work scopes. The first scope is R&D and design of a commercial scale ship to transport CO2 at a scale of 1 million tons per year. The second scope is to build and operate a ship to transport CO2 at 10,000 tons per year to Tomakomai. The third scope is the study of ship transportation business models. This slide is further explanation of Scope 2 demonstration project. We plan to demonstrate CO2 ship transportation by capturing and liquefying CO2 at a coal-fired power plant in Maizuru City and transporting it to Tomakomai. The plan is to build and operate a ship with gross tonnage of approx 1,000 tons to transport CO2 to Tomakomai. We aim to start the ship transportation demonstration in 2024, which will be the world's first CO2 ship transportation for CCUS. Next, for the investigation of potential CO2 storage sites. This slide shows the schedule of storage site survey project in Japan. The survey work has been commissioned to Japan CCS since 2014, and we have conducted 2D and 3D seismic surveys. The target is to select about 3 candidate sites for survey well drilling from a comprehensive perspective among prospective sites suitable for CO2 storage by around fiscal year 2023. This slide shows the result of the storage capacity evaluation of offshore Japan as of March 2020. The estimated amount of storage capacity within the surveyed range is 9 billion tons by 3D survey, 3 billion tons by dense 2D survey, and 43 billion tons by rough 2D survey. The entire sedimentary basin has not been evaluated, and there is a possibility of huge additional potential. As I already mentioned, we aim to select about 3 candidate sites for survey well drilling by around fiscal year 2023. This concludes my presentation. Thank you for your attention.
Thank you very much, Mr. Sada. Today, we have introduced the Asia CCUS network and the Tomakomai project. We have high expectations that CCUS will be widely deployed in Asia and the world. Thank you very much for joining us. This concludes the Japan CCS session. We would like to thank the New Energy and Industrial Technology Development Organization for their support.